Hello student, now in this video we will solve the exercise 6.3, that is a solution of the differential equation. I will explain all the examples from the exercise 6.3. Now let us start. Solution of differential equation. Y is equals to a sin x and differentiate this with respect to x. Therefore dy by dx is equals to a is a constant, derivative of sin x is cos x. And that's why a is equals to y upon sin x. Substitute the value of this a in this equation, y is equals to a sin x, and then you will get dy by dx is equals to y upon sin x into cos x. And therefore, this y upon sin x into cos x, and that is a cos x upon sin x, that will become cot x. Therefore, dy by dx is equals to y cot x. This is differential equation whose solution is y is equals to a sin x. Now the particular solution. A solution which can be obtained from the general solution by giving the particular values to the arbitrary constants is called a particular solution. Now we will see by using these examples. And now let us start the exercise 6.3. In each of the following examples, verify that the given expression is a solution of the corresponding differential equation. Now we will verify this. xy is equals to log y plus c. Therefore, dy by dx is equals to y square upon 1 minus xy. Now see this here. xy is equals to log of y plus c. Now differentiate this. This is a solution of this differential equation. Now differentiate this with respect to x. That is, differentiate this xy is equals to a log of y plus c. Apply the product rule. That is, first keep x as it is. Derivative of y is a dy by dx plus y into derivative of x is 1, and that's equals to derivative of y is log of y is 1 upon y into dy by dx, and derivative of c as a constant, and its a derivative is 0. Therefore, take the terms of the dy by dx on the left hand side, that is x into dy by dx minus 1 upon y into dy by dx, that's equals to minus y. Take dy by dx as a common, then in bracket you will get x minus 1 upon y, and if you simplify it, then you will get xy minus 1 upon y, that's equals to minus y, and that's why dy by dx is equals to minus y square upon xy minus 1. If you take the minus sign from the denominator, and then this minus will become plus, and therefore dy by dx is equals to y square upon 1 minus xy, and hence the solution is verified. Now next, y is equals to the sine inverse of x square bracket square plus c, and its equation is 1 minus x square d2y by dx square minus x into dy by dx, that's equals to 2. Now y is equals to sine inverse of x bracket square plus c. Differentiate this with respect to x. Derivative of y is a dy by dx, and derivative of sine inverse of x, that is a 2 sine inverse of x into derivative of sine inverse of x, which is 1 upon in under root of 1 minus x square, and derivative of c is a 0. And therefore, if you simplify this, that is, you will get in under root of 1 minus x square into dy by dx is equals to 2 sine inverse of x. Now squaring on both sides, and then you will get that is 1 minus x square dy by dx bracket square, that's equals to 4. That is, if we square this, then you will get 4 sine inverse of x bracket square. Now next, again differentiate this equation with respect to x. To the left hand side, we will apply the product rule. Now 1 minus in bracket 1 minus x square, and the derivative of dy by dx bracket square, it's a power function. That is a 2 into dy by dx, and again derivative of dy by dx is a d2y by dx square. It's a composite again. Plus, keep the dy by dx bracket square as it is, and then find the derivative of 1 minus x square. The derivative of 1 minus x square is, that is the derivative of 1 is 0 and x square is a minus 2x. And to the right hand side, that is a 4 sine inverse of x bracket square. Now the derivative of 4 into sine inverse of x square, that is sine inverse of x bracket square. It's again here is a power, that is a 4 into 2, 8. 8 sine inverse of x into derivative of sine inverse of x. What's the derivative of sine inverse of x? Into 1 upon in under root of 1 minus x square. And now we will simplify here. That is 1 minus x square as it is, and 2 into dy by dx in bracket into d2y by dx square. Next term is a minus 2x into dy by dx bracket square. And the next, that is 8 sine inverse of x can be written as 2 sine inverse of x into 4 upon in under root of 1 minus x square, because that is a 2 sine inverse of x. In place of the 2 sine inverse of x, we will substitute here the value. What is the value of the 2 sine inverse of x? That is in under root of 1 minus x square into dy by dx. Substitute here. That is in under root of 1 minus x square into dy by dx. Now here root of 1 minus x square and root of 1 minus square get cancelled, and you will get 1 minus x square into d2y by dx square in bracket 2 dy by dx minus x into dy by dx, and in the next bracket 2 into dy by dx, and overall you will get, that is this 4 into dy by dx can be again written as 2 in bracket 2 into dy by dx. Now from the both sides, see these underlined terms, which are that 2 into dy by dx, 2 into dy by dx, 2 into dy by dx, it gets cancelled, and then you will get 1 minus x square into d2y by dx square minus x into dy by dx, and that's equals to 2, and hence it's a verified. Now the next equation, y is equals to e raised to minus x plus ax plus b, and it's a differential equation, is e raised to x into d2y by dx square, that's equals to 1. Now y is equals to e raised to minus x square, that is equals to ax plus b. Now differentiate this with respect to x. Derivative of y is dy by dx. Derivative of e raised to minus x is minus e raised to x, because e raised to minus x, derivative of e raised to minus x is e raised to minus x into derivative of minus x, which is minus 1. Derivative of ax, the derivative of x is 1. 1 into a is a, and plus b, the derivative of b is 0, because it's a constant. Therefore dy by d. Now next, dy by dx is equals to minus e raised to minus x plus a. Again differentiate this with respect to x. Therefore you will get d2y by dx square is equals to, again derivative of e raised to minus x is e raised to minus x, but again derivative of minus x is minus 1. Again this minus and minus, that will become plus, and here it is a e raised to minus x. Therefore d2y by dx square is equals to 1 upon e raised to x. Therefore e raised to x into d2y by dx square, that's equals to 1, and this is the verified. Now the next problem number 4. Y is equals to x raised to m, and verify that x square into d2y by dx square minus mx into dy by dx plus my, that's equals to 0. Now here y is equals to x raised to m. It's a derivative. Differentiate this with respect to x. Therefore dy by dx is equals to m into x raised to m minus 1. Again differentiate this with respect to x. Then you will get d2y by dx square, that's equals to m into, what's the derivative of x raised to m minus 1? Here is m minus 1 into x raised to m minus 2. Multiply on both sides by x square. Then you will get x square into d2y by dx square, that's equals to m in bracket m minus 1 into x raised to 2. And here is a x raised to m minus 1 into x raised to 2. Then you will get x raised to m. That is plus 2 and minus 2 get cancelled. You will get x raised to m. But what is the value of x raised to m? That is nothing but the y. And hence that is a x square d2y by dx square equals to m in bracket m minus 1 into y. And that's why x square d2y by dx square is equals to m in bracket m minus 1 into y. And this is equation number 1. What about the next? dy by dx is equals to m into x raised to m minus 1. Multiply on the both sides by mx. If you multiply it, then you will get m into x into dy by dx. That's equals to m into x into m into x raised to m minus 1. आपण असं का करत आहोत? कारण की आपल्याला हे डिफरन्शियल असं इक्वेशन दिलं आहे. First we will find out the value of x square into d2y by dx square. Then we will find out the value of mx into dy by dx. And lastly we will find out the value of my. And we will add all these terms. Now see this here. Therefore, mx into dy by dx is equals to m into x raised to m minus 1. Therefore, mx into dy by dx is equals to m square into x raised to m. This is number 2. And the last is y is equals to x raised to m. What about that? Here is a third term. Is a my, and therefore we'll multiply with by m. That my is equals to m into x raised to m. This is equation number 3. And therefore from 1 to 3, this is the 1, 2 and 3. Therefore you will get x square d2y by dx square minus mx into dy by dx plus my, and that's equals to m in bracket. All the terms has their right hand sides. What is the first? That is the first is m in bracket m minus 1 into y. And here is a m in bracket m minus 1 into y. What about the second? That is m square and x raised to m minus m square into x raised to m. And what about the third? Third is m into x raised to m, and this is. And now simplify this. Then you will get that is a m into m square into 1, that is a minus m into x raised to m minus m square x raised to m plus m x raised to m. And if you simplify this, then you will get m square x raised to m minus m x raised to m minus m square x raised to m plus m x raised to m. All the terms get cancelled, and that's equals to 0. And hence the equation is verified. That x square into d2y by dx square minus mx into dy by dx plus my is equals to 0 is verified. Now the next is y is equals to a plus b upon x. What's the differential equation? X into d2y by dx square plus 2 into dy by dx, that's equals to 0. Now first y is equals to a plus b upon x. Differentiate this with respect to x. The derivative of y is dy by dx, derivative of a, it's constant, that's derivative 0. Plus b upon x, what's the derivative of 1 upon x? Is minus 1 upon x square. And therefore dy by dx is equals to minus b upon x square. This is equation number 1. Next, again differentiate this with respect to x. Then you will get d2y by dx square is equals to plus. What's the derivative of x, 1 upon x raised to 2? That will become x raised to minus 2. And this minus and minus will become plus. That is a 2b upon minus 2 minus 1. That will become minus 3. And bring that term to the denominator. It will become 1 upon x raised to 3. And therefore, d2y by dx square is equals to 2b upon x cube. This is equation number 2. And if we simplify this, if we arrange these terms like this, that x into d2y by dx square plus 2 into dy by dx, that's equals to, if we arrange these terms, then what is the value of that is x into d2y by dx square, that is x into 2b upon x cube, and 2 into dy by dx, that is a plus 2 into minus b upon x square. म्हणजे या इक्वेशन मध्ये dy by dx and d2y by dx square च्या व्हॅल्यूज आपण टाकणार आणि ते सिम्प्लिफाय करणार. Then you will get plus 2b upon x square minus 2b upon x square, and that gets 0. And hence you will get that is the required solution, differential equation. That x into d2y by dx square plus 2 into dy by dx, that's equals to 0. It's verified. Now the next solution, y is equals to e raised to x. And what's the differential equation? X into dy by dx is equals to y log y. Now the solution y is equals to e raised to x. Differentiate this with respect to x. The derivative of y is the dy by dx is equals to a into e raised to x. Therefore multiply to the both sides by x. X into dy by dx is equals to a into x into e raised to x. And therefore you will get x into dy by dx is equals to e raised to ax in bracket ax. But so what is the value of ax? Now see this here. Y is equals to e raised to x. Now this exponential function can be turned into the logarithm function. That is a log of y. Take log on both sides. Then you will get log of y is equals to ax. Therefore the value of ax, that is a log y. And therefore x into dy by dx, that is equals to x into dy by dx, that is equals to y into log y. And in this way it is verified. Now the question number 2. Solve the differential equation, that is the dy by dx is equals to 1 plus y square upon 1 plus x square. Now first of all make the cross multiplication here. That is 1 plus x square into dy is equals to 1 plus y square into dx. Now separate the variables. How to separate it? That is a divide on both sides by 1 plus x square into 1 plus y square. Then automatically the terms will be separable, variable will be separate. व्हेरिएबल सेपरेट म्हणजे काय की dx च्या खाली x चे टर्म्स आले पाहिजेत आणि dy च्या खाली y चे टर्म्स आले पाहिजेत. That is a dx upon 1 plus x square and dy upon 1 plus y square. And therefore dx upon 1 plus x square minus dy upon 1 plus y square, that's equals to 0. Now integrate on both sides. Then what you will get? This is the result for the tan inverse of x and tan inverse of y. And the integration of this constant, that is a 0, is a c. Integrating on both sides, then you will get tan inverse of x minus tan inverse of y, that's equals to c. And therefore tan inverse of y is equals to tan inverse of x plus c. And this is the required differential equation. Now the next question, log of dy by dx is equals to 2x plus 3y. Therefore, log of dy by dx is equals to 2x plus 3y. Therefore, dy by dx is equals to e raised to 2x plus 3y. Therefore, dy by dx is equals to e raised to 2x into e raised to 3y. Now, separate the variable. That is, after separating the variable, dy upon e raised to 3y. So, dy च्या खाली y चे terms आणायचे. And now dx upon dx into e raised to 2x. Now again this can be written as that is a e raised to 2x into dx minus e raised to minus 3y into dy, that's equals to 0. Now integrating on both sides, then you will get, what is the integral of e raised to 2x? The integral of e raised to 2x is e raised to 2x upon 2 minus integral of e raised to minus 3y is e raised to minus 3y upon minus 3, and that's equals to c1. And again simplifying, you will get that is e raised to 2x upon 2 minus minus will become plus, therefore e raised to minus 3y upon 3, that's equals to c1. After the cross multiplication, then you will get 3 into e raised to 2x plus 2 into e raised to minus 3y, that's equals to 6c1. And therefore 3 e raised to 2x plus 2 into e raised to minus 3y, that is equals to c, where 6c1 is equals to c, and this is the required differential equation. Y minus x into dy by dx, that's equals to 0. Therefore y is equals to x into dy by dx. Then separate the variables or make this cross multiplication, then you will get y into dx is equals to x into dy. पुन्हा दोन्ही साइडला आपण xy ने डिवाइड करणार. If we divide on the both side by xy, then you will get y dx upon xy, that is y get cancelled, then you will get dx upon x. Again here is x into dy upon xy. X's get cancelled, you will get dy upon y. Now integrating on both sides, then you will get log of x is equals to log of y plus log of c. आता इथे कॉन्स्टंट आपण c नाही घेतला. सर्व टर्म्स जर लॉग मध्ये येत असतील तर त्याच्यातला कॉन्स्टंट देखील लॉग मध्येच घ्यायचा असतो या प्रकारे. If all the terms are in the log function, then we treat the constant is also in the form of the log c, and therefore you will get that is a log of x is equals to log of y plus log of c. log चा इथे रूल अप्लाय करणार आहे आपण इथे. That is a log of m plus n means what? Log of mn. In the same way, log of x is equals to log of xy. Cancel on both sides. That is a log out. Take anti-log on both sides. Then you will get x is equals to yc, and therefore x is equals to yc. This is the required differential equation. Now the next problem, that is a sec square x into tan y into dx plus sec square y into tan x into dy, that's equals to 0. Now separate the variables. It means that आता इथे dx आहे, मग कोणकोणती टर्म्स x ची टर्म पाहिजे होती, मग इथे कोण नको पाहिजे आपल्याला? tan y नको पाहिजे. तर इथे dy इथे कोण नको पाहिजे? तर tan x नको पाहिजे. मग जे नको असणारे पाहिजे त्यांचा आपण ग्रुप तयार केला. What is that group? That group is a tan x into tan y, and then divide on both sides by tan x into tan y, and then automatically the variable will be the separate. Therefore sec square x into tan y into dx upon tan x into tan y plus sec square y into tan x into dy upon tan x into tan y. That is, here is a tan y and tan y get cancelled. Sec square x upon tan x dx plus sec square y upon tan y into dy, that's equals to 0. Integrating on both sides. Now what's happening here? F dash of x upon f of x dx plus integral f dash of x upon f of f dash of y upon f of y into dy. That, and what about their constant? We know that it is in the form of the log form. सगळ्यांची इंटिग्रेशन हे कोणत्या फॉर्म मध्ये, तर लॉग फॉर्म आहे. म्हणून इंटिग्रल sec square x upon tan x, its integral is the log of tan x. And what about the integral of this? That is the log of tan y, and that's equals to log c. Therefore, log of tan x into tan y is equals to log c. And take antilog on both sides, then you will get tan x into tan y, that's equals to c. This is the required solution. Now the next is a cos x into cos y into dy minus sin x into sin y into dx, that's equals to 0. Now what's happening again here? Here is a dy, which terms that we do not require here, that is a cos x. What about here? Here is a dx and here is a sin y. Therefore, take the multiplication of these two terms, that is separate the variable, divide on the both side by cos x into sin y. And if you divide on the both side by the cos x into sin y, that is you will get cos x into cos y into dy upon cos x into sin y minus sin x into sin y into dx upon cos x into sin y, that's equals to 0. Now in this case, what's happening? That is cos x get cancelled, cos of y upon sin of y. That will become cot of y into dy minus, again here sin y get cancelled, you will get sin x upon cos x, that is a tan x into dx. Now integrating on both sides, very nice integration. This is the integral of cot x and the integral of tan x. What is the integral of cot x? Is the log of sin y, and the integral of tan x is the log of sec x. And what about their constant? The constant is also in the form of the log, that is the log of c. Now here we will apply the properties of the log, that is the log of m minus log of n. That is nothing but the log of m upon n. And here is the log of sin of y upon sec x is equals to log c. Now take antilog on both sides, then you will get, that is a sin y into cos x is equals to c. And therefore the sin y into cos x, that's equals to c. This is the required solution. Now the next, dy by dx is equals to minus k, where k is a constant. Therefore dy by dx is equals to minus k, therefore dy is equals to minus kx. Now here is already the variables are separable. Now integrating on both sides, that is integral dy is equals to minus k into integral dx plus c. What is the integral of dy is y, integral of dx is x, and plus c. Therefore y is equals to minus kx plus c. And this is the required solution of the differential equation. Now the next is cos square y into dy upon x plus cos square x into dx upon y, that's equals to 0. Now which term we do not require here? To make the variable separable, that's we will multiply on both sides by xy. म्हणजे इथे काय नको पाहिजे, तर x डिवाइड नको पाहिजे, इथे काय नको पाहिजे, तर y डिवाइड नको पाहिजे. Now in this case we will multiply it. Instead of dividing, here we will multiply the xy. Instead of dividing, here we will multiply by xy. Note this step. That is xy into cos square y into dy upon x plus xy into cos square x into dx upon y, that's equals to 0. Now here x get cancelled and you will get, that is y cos square y into dy plus x cos square x into dx, that's equals to 0. Now what is the formula for the cos square y? It's 1 plus cos of 2y upon 2 into dy plus x into cos square x, 1 plus cos of 2x upon 2 into dx, that's equals to 0. Now integrating separate, that is a multiply again both sides by 2, then you will get y in bracket 1 plus cos of 2y into dy plus x in bracket 1 plus cos of 2x into dx, that's equals to 0. Therefore overall you will get y plus y into cos of 2y into dy plus x cos of 2x into dx, that's equals to 0. Integrating on both sides. Now here we will take as a constant as a c. Now what is the integral of y? It's a y square upon 2. What is the integral of y into cos of 2y? By, now we will solve this by using the integration by parts. What is the integral of this x? That is x square upon 2. And x cos of 2x into dx, we will solve this integral by the integration by parts. Now see this here. The first integral integral of y is y square upon 2. Now next y cos of 2y. Now here first of all we will apply here algebraic and the trigonometry. The first function is algebraic, that is the y integral of cos of 2y, that is first function into integral of the second, minus integral derivative of the first, that is the dy of y, into integral of cos of 2y bracket complete into dy, plus integral of x is x square upon 2. Again we will apply here the integration by parts for this x cos of 2x. Again the first function, which is the x, integral of cos of 2x minus integral of derivative of the first, that is x, into integral of cos of 2x bracket complete into dx, that's equals to c. Now see this here, y square upon 2. The integral of cos of 2y is sine of 2y upon 2 minus. What is the derivative of y? Is 1. Integral of cos of 2y is sine of 2y upon 2 plus x square upon 2. What is the integral of cos of 2y? Cos of 2x is a sine of 2x upon 2 into x, and the integral, what is the derivative of x? Is 1. What is the integral of cos of 2x? Is a sine of 2x upon 2 into dx, that's equals to c. Now here y square upon 2 plus y sine of 2y upon 2, and here is a next term is a, what is the integral of sine of 2y upon 2? It's a minus cos of 2y upon 2, that will become 4, and this is a minus and minus, that will become plus. Therefore minus integral of sine of 2y upon 2 is a cos of 2y upon 4. X square upon 2, this term is as it is, x sine of 2x upon 2, this is also as it is. Again the integral of minus sine of 2y upon 2 into dx. The integral of sine of 2x, integral of sine of 2x is a cos of 2x upon 2, that 2 will become here 4, and the its sign is a minus, and again minus minus will become plus, that is the cos of 2x upon 4, that's equals to c. Now see this here, like terms. Which are the like, that is the terms, that is x square upon 2 plus y square upon 2. What about the next terms? That is y sine of 2y upon 2 plus x sine of 2x upon 2. And what about the next? Here is a divided by 4 divided by 4. Take 1 by 4 as common, and then in bracket you will get cos of 2x plus cos of 2y, that's equals to c1. Now see this here, multiply on both sides by 4, that is LCM is 4, and then you will get, that is a 2 in bracket x square plus y square, and if we take the common 1 upon 2 and multiply it with by 4, then you will get 2 in bracket x sine 2x plus y sine 2y. And what about here? I had repeated that step here, that is a 2 in bracket x square plus y square plus 2 in bracket x sine 2x plus y sine 2y bracket complete plus cos 2x plus cos of 2y plus c, that's equals to 0. Here I had replaced, that is a minus 4c1 is equals to c, that's a constant, and therefore the final answer, that is the final solution of that differential equation, is 2 in bracket x square plus y square plus 2 in bracket x sine 2x plus y sine 2y bracket complete plus cos 2x plus cos of 2y plus c, that's equals to 0. Now the next problem, that is a y cube minus dy by dx is equals to x square into dy by dx. Now bring these the terms of the dy by dx to the right hand side. Then you will get y cube is equals to x square into dy by dx plus dy by dx. Take dy by dx as a common. Then you will get y cube is equals to x square plus 1 into dy by dx. Now separate the terms. That is, you will get dx upon 1 plus x square, that is equals to dy upon y cube. Therefore, next step is integrating on both sides. And therefore, you will get that the integral dx upon x square plus 1 minus integral y raised to minus 3 into dy, that is equals to c1. Now what is the integral of dx upon x square plus 1, that is the tan inverse of x. And what is the integral of y raised to minus 3, that is a y raised to minus 3 plus 1, that is a y raised to minus 2. And upon that minus 2, this minus and minus will become plus, then you will get tan inverse of x plus 1 upon 2y square, that's equals to c1. Now simplify this, then you will get, that is the 2y square tan inverse of x plus 1, that's equals to 2c1y square. Now replace 2c1 by c, and therefore 2y square tan inverse of x plus 1, that is equals to cy square. This is the required solution. Now the next problem is 2 e raised to x plus 2y into dx minus 3 dy, that's equals to 0. Now again this can be written as, that is a 2 into e raised to x into e raised to 2x into dy, that minus 3 dy, that's equals to 0. Now separate the variable. Now it can be written as in this manner, that is a 2 into e raised to x upon e raised to minus 2x into dx minus 3 dy, and therefore again after simplifying, then you will get, that is a 2 into e raised to x into dx minus 3 e raised to minus 2y into dy, that's equals to 0. Now integrating on both sides, that is a 2 integral e raised to x into dx minus 3 integral e raised to minus 2y into dy, that's equals to 0. What's the integral of e raised to x? The integral of e raised to x is e raised to x minus 3. Integral of e raised to minus 2y is e raised to minus 2y upon minus 2 is equals to c. And this minus minus will become plus, and that's 2 e raised to x plus 3 by 2 e raised to minus 2y, that's equals to c. And again simplifying, then you will get, that is a 4 multiplied on both sides by 2. Then you will get 4 e raised to x plus 3 e raised to minus 2y, that's equals to 2c, and then 2c is replaced by c, and overall whatever that c, then overall you can write at the last, that is a c. This is the required differential equation. Now the problem number 10. dy by dx is equals to e raised to x plus y plus x square into e raised to y. Again e raised to x plus y can be written as e raised to x into e raised to y plus x square into e raised to y. Now from this multiply or simplify this, that is a dy is equals to take the e raised to y as a common, then in bracket you will get x square plus e raised to x into dx. Now separate the variables, that is a divide on both sides by e raised to y. Then you will get e raised to y, dy upon e raised to y, that is equals to e raised to x plus x square into dx. And again it is written as like this, that is e raised to minus y into dy, that is equals to x square plus e raised to x into dx. या प्रकारे आपण ते सिम्प्लिफाय करू शकतो. Now next, integrating on both sides, that is integral of x square plus e raised to x into dx minus integral e raised to minus y dy, that's equals to c1. What's the integral of x square? Is x cube upon 3. E raised to x integral is e raised to x. Integral of e raised to minus e raised to minus y upon minus 1, that is equals to c1. And again simplification, then you will get x cube upon 3 plus e raised to x plus e raised to minus y, that's equals to c1. And if you multiply on both sides by 3, then you will get x cube plus 3 e raised to x plus 3 into e raised to minus y, that's equals to 3c1, and replace the value of 3c1 as c. And therefore the x cube plus 3 e raised to x plus 3 e raised to minus y, that's equals to c. This is the required differential equation. Now the question number 3. For each of the following differential equations, find the particular solution satisfying the given condition. It means that here we will find out the value of the c, that is the particular solution. Now the first is 3 e raised to x into tan y dx plus in bracket 1 plus e raised to x into sec square y into dy, that's equals to 0. When x is equals to 0, y is equals to pi. These are the values for the particular solution. Now again the same job, that is a 3 into e raised to x into tan y into dx plus in bracket 1 plus e raised to x into sec square y into dy, that's equals to 0. Now separate the variables. Now we'll divide on both sides by, that's a tan y into in bracket 1 plus e raised to x. हे कसं फाइंड आउट करायचं मी यापूर्वी सांगितलं तुम्हाला. या dx इथे टर्म आहे, इथे काय नको पाहिजे तर tan y नको पाहिजे, म्हणून आपण इथे tan y घेतलाय. इथे dy आहे आणि इथे काय नको पाहिजे तर 1 plus e raised to x नको पाहिजे, म्हणून आपण इथे 1 plus e raised to x घेतला in bracket. Therefore divide on both sides by tan y into in bracket 1 plus e raised to x, and therefore the tan y get cancelled, and here is a 1 plus e raised to x, 1 plus e raised to x from the numerator denominator get cancelled, and therefore you will get 3 e raised to x upon 1 plus e raised to x dx plus sec square y upon tan y into dy, that's equals to 0. Now integrating on both sides, then you will get 3 integral e raised to x upon 1 plus e raised to x into dx plus integral sec square y upon tan y into dy, and that's equals to log c. म्हणजे आपल्याला असं माहिती पण पाहिजे की हा c कोणत्या प्रकारचा इथे घेतला पाहिजे. It's clear that the integral of e raised to x upon 1 plus e raised to x is in log form. Integral of the sec square y upon tan y is in the log form, and that's why I had taken the constant is also in the log of c. Therefore, the 3 log of in bracket 1 plus e raised to x plus log of tan y, that's equals to log c. And here is by using the properties of the logarithm, that is m into log of n means what? Log of n raised to m, and therefore log of 1 plus e raised to x whole bracket raised to 3 plus log of tan y, that's equals to log c. Again, by using the properties of the log, that is the addition of these two log means multiplication, and cancel on both sides by log terms, or take the antilog on both sides, then you will get 1 plus e raised to x bracket cube into tan y, that's equals to c. Now we have given that the value of for the particular solution साठी आपल्याला त्याने x आणि y च्या व्हॅल्यूज दिल्यात, that x is equals to 0 and y is equals to pi. Substitute x is equals to 0 and y is equals to pi in this equation. Now what is the tan pi? Tan pi is a 0, and whatever that 1 plus 2 bracket is to 3 is 8. 8 into 0 is 0, therefore value of the c is 0. Therefore the particular solution is 1 plus e raised to x bracket cube into tan y, that's equals to 0. And this is the required particular solution. What is that? 1 plus e raised to x bracket cube into tan y, that's equals to 0. Now the next problem, that is in bracket x minus y square into x bracket complete into dx minus y in bracket y plus x square y bracket complete into dy, that's equals to 0. And what are the values of x and y? X is equals to 2 and y is equals to 0. Now we'll find out the solution from this differential equation. Now from the first term, take x as common. Then in bracket you will get 1 minus y square into dx. From this term, take y as common. That is minus y in bracket 1 plus x square into dy, that's equals to 0. Again कोणती टर्म्स नको पाहिजे, या dx ला 1 minus y square नको पाहिजे म्हणून आपण तो इथे घेतला. dy ला कोण नको पाहिजे, तर 1 plus x square नको पाहिजे, तो घेतला. Therefore, divide on both sides by 1 minus y square into 1 plus x square. And then you will get, after dividing, you will get that is x upon 1 plus x square dx minus y upon 1 minus y square into dy, that's equals to 0. Now again multiplied on both sides by 2, then 2x upon 1 plus x square into dx plus minus 2y upon 1 minus y square into dy, that's equals to 0. Now integrating on both sides, it's very simple. That f dash of x upon f of x, it's in the log form. म्हणून इथे कॉन्स्टंट देखील आपण log c च्या फॉर्म मध्ये घेतलेला आहे. That is integral 2x upon 1 plus x square dx plus integral minus 2y upon 1 minus y square into dy, that's equals to log c. And therefore log of 1 plus x square plus log of 1 minus y square is equals to log c. After applying the properties of log of m plus log of n, that is the log of m into n, that is the log of in bracket 1 plus x square into in bracket 1 minus y square is equals to log c. Now taking the antilog on both sides, then you will get 1 plus x square into 1 minus y square, that is equals to c. Now for the particular solution, to find out the value of c, put x is equals to 2 and y is equals to 0. Then you will get, if you substitute x is equals to 2, then you will get log of in bracket 1 plus 2 raised to 2 in bracket the value of y is 0, and here is a 1 minus 0, that's equals to c, log c. Therefore the log of phi is equals to log c. Put in equation number 1, then you will get log of in bracket 1 plus x square in bracket 1 minus y square, that is equals to log of 5. Now take antilog on both sides, and then you will get 1 plus in bracket 1 plus x square in second bracket 1 minus y square, that's equals to 5. This is the particular solution. Now the problem number 3. Now the next question is y in bracket 1 plus log x into dy upon dx minus x log x is equals to 0, where y is equals to e raised to 2 when x is equals to e. Therefore see this equation, that is y in bracket 1 plus log x into dy by dx minus x log x is equals to 0. It is written as in this manner, y in bracket 1 plus log x into dy by dx is equals to x log x. Now separate the variables, or it is written as in this manner, that is y in bracket 1 plus log x into dx is equals to x log x into dy. Now again divide on both sides by y x log x. जे इथे dx आहे मग काय नको पाहिजे तर y नको पाहिजे. इथे dy काय नको पाहिजे तर x log x नको पाहिजे. म्हणजेच ओव्हरऑल काय नको पाहिजे आपल्याला y x log x नको पाहिजे. And that's why divide on both sides by y x log x on both sides. Therefore you will get y into in bracket 1 plus log x into dx upon y x log x, that's equals to x log x into dy upon y x log x. And here y will get cancelled and you will get that is a 1 plus log x upon x log x dx, and that's equals to here log x and log x get cancelled, you will get dy upon y, and therefore that is 1 plus log x upon x log x dy minus dy upon y, that's equals to 0. Now integrating on both sides, then you will get integral 1 plus log x upon x log x into dx minus integral dy upon y, that's equals to log c. पुन्हा इथे कॉन्स्टंट आपण log c असा लिहिलेला आहे, शेवटी कॉन्स्टंट नंतर लिहिला तरी चालू शकतो. If we integrate integral dy upon y, its integration is a log of y, and that's why it's a log c. Now here is a 1 plus log x upon x log x dx. Now we'll integrate this by using the method of substitution. Put x is equals to log x, that's equals to t. Now differentiate on both sides. Then you will get apply the product rule. याला product rule आपण इथे apply करणार. Keep x as it is. Derivative of log of x is 1 upon x plus derivative of x is 1 into log x bracket complete into dx is equals to dt. Here x get cancelled, then you will get 1 plus log x bracket complete into dx is equals to dt. What about our integral? That our integral will become that integral dt upon t. dt upon t minus log y is equals to log c, and therefore it is a integral dt upon t integral, its integral is a log t minus log of y is equals to log c. Now again log of m minus log of n means what? Log of m upon n means log of t upon y, that's equals to log c. Take antilog on both sides and then you will get t upon y is equals to c. Therefore substitute the value of t. What's the value of t? T is equals to x log x, and here we will substitute x log x upon y is equals to c. Therefore x log x is equals to cy, and this is the general solution. What about the particular solution? We have given that y is equals to e raised to x square when x is equals to e. Now put y is equals to e raised to x square and x is equals to e. That is, substitute here x is equals to e log of e is equals to c e raised to 2, and therefore log of e. What is the value of log of e? Its a base is e. If its value is 1, therefore 1 into e is e. E is equals to c into e square. What about the value of this c? C is equals to this 1 e get cancelled, and therefore c is equals to 1 upon e. Put this value of c, which is 1 upon e, in equation number 2, and then you will get the particular solution. That is x log x is equals to 1 upon e into y, and therefore y is equals to ex log x, and therefore y is equals to ex log x. This is the required particular solution. Now the next problem is problem number 4. In bracket e raised to y plus 1 into cos x plus e raised to y into sin x into dy by dx, that's equals to 0. When x is equals to pi by 6, y is equals to 0. Now see this differential equation. E raised to y plus 1 into cos x plus e raised to y into sin x into dy by dx, that's equals to 0. Again simplify, that is multiplied on both sides by dx, then you will get e raised to y in bracket e raised to y plus 1 into cos x into dx plus e raised to y into sin x into dy is equals to 0. Now divide on both sides by e raised to y plus 1 into sin x. Why it is? That's I had explained. Which terms do not require here for the dx? dx साठी कोणते टर्म्स नको पाहिजे? e raised to y plus 1 नको पाहिजे, आणि dy साठी कुठलं नको पाहिजे तर sin x नको पाहिजे. Therefore divide on both sides by e raised to y plus 1 into sin x. That is e raised to y plus 1 into cos x into dx upon e raised to y plus 1 into sin x plus e raised to y into sin x upon dy upon e raised to y plus 1 into sin x, that's equals to 0. Therefore, e raised to y plus 1, e raised to y plus 1 on both sides get cancelled. Cos x upon sin x, that will be the cot x. And in this case, sin x get cancelled, e raised to y upon e raised to y plus 1. Now here is a cot x into dx plus e raised to y upon e raised to y plus 1 into dy, that's equals to 0. Now integrating on both sides, what is the integral of cot x dx? That is a log of sin x. And what is the integral of e raised to y upon e raised to y plus 1 into dy? That is a log of e raised to y plus 1, that's equals to log c. And therefore, by using the use of that is the properties of the logs, that is the log of sin x into e raised to y plus 1, that's equals to log c. Taking the antilog on both sides, then you will get that is a sin x into in bracket e raised to y plus 1, that's equals to c. This is equation number 1. But we have given that x is equals to pi by 6 and y is equals to 0. Put x is equals to pi by 6, that is the sine of pi by 6, e raised to 0 plus 1, that's equals to c. But what is the value of sine 30 is 1 upon 2, e raised to 0 is 1, plus 1, that's equals to c. 2 upon 2, then you will get the value of c is 1. And therefore, put here 1. And therefore, the sin x in bracket e raised to y plus 1 bracket complete, that's equals to 1. This is the particular solution. Now the next is in bracket x plus 1 into dy by dx minus 1 is equals to 2 e raised to minus y is equals to 0 and x is equals to 1. Now here we can write that is the in bracket x plus 1 into dy by dx minus 1 is equals to 2 e raised to minus y. That is after simplifying, then you will get that is a x plus y into dy by dx, that's equals to 2 upon e raised to y plus 1. If we simplify this, then you will get 2 plus e raised to y upon e raised to y. And after separating these, again simplifying, that is a x plus 1 into dy is equals to, this is divided by, it will come to the right hand side and multiplied to this term. That is a 2 plus e raised to y upon e raised to y into dx. Therefore, you will get 2 plus e raised to y upon e raised to y into dx minus in bracket x plus 1 into dy, that's equals to 0. Now divide on both sides by which terms do not record for this x dx is 2 plus e raised to y upon e raised to y. What about here? In bracket x plus 1. Therefore, divide on both sides by e raised to y plus 2 upon e raised to y into in bracket x plus 1. After dividing, then you will get dx upon x plus 1 minus e raised to y upon e raised to y plus 2 into dy, that's equals to 0. Now this integral is very simple. Integrate on both sides, that is integrating on both sides, dx upon x plus 1 minus integral e raised to y upon e raised to y plus 2 into dy, that's equals to log c. And that's integral of this dx upon x plus 1 is a log of x plus 1 minus log of e raised to y plus 2, that's equals to log c. It's of the form f dash of x upon f of x, and therefore by using the properties of log, that is subtraction is here, that will log of x plus 1 upon e raised to y plus 2, that's equals to log c. Take antilog on both sides, then you will get x plus 1 upon e raised to y plus 2 is equals to c. Now the particular solution, that is y is equals to 0, x is equals to 1, put here. Then you will get the value of x is 1, 1 plus 1, e raised to 0 is 1, 1 plus 2, that is a 3. That is a 2 upon 3, the value of c is a 2 upon 3. Put this value of c here, which is a 2 upon 3, and therefore you will get after multiplication, that is a x plus 1 upon e raised to y plus 2 is equals to 2 upon 3, and therefore you will get this particular solution. What is that? 3 in bracket x plus 1 is equals to 2 in bracket e raised to y plus 2, and therefore this is the particular solution. Now the next problem, cos of dy by dx, that is equals to a, where a belongs to set of real number and y of 0, that is equals to 2. That is when x is equals to 0, the value is 2. That is now cos in bracket dy by dx is equals to a. Therefore dy by dx is equals to cos inverse of a. Therefore dy is equals to cos inverse of a into dx. And integrating on both sides, integral of dy is equals to integral of cos inverse of a dx plus c. Therefore integral of dy is y, cos inverse of a is a constant, integral of dx is x plus c. Therefore, y is equals to x cos inverse of a plus c is equal. This is the question number 1. This is general solution. When y of 0 is 2, means what, x is equals to 0 and y is 2. Therefore, substitute y is equals to 2 and x is equals to 0. That is 2 is equals to 0 into cos inverse of a plus c, and therefore the value of c is 2. Put this value of c in this equation, that is equation number 1. Then you will get y is equals to x cos inverse of a plus 2, and therefore y minus 2 is equals to x cos inverse of a. Therefore cos inverse of a is equals to y minus 2 upon x, and therefore a is equals to cos of y minus 2 upon x, and therefore the cos of y minus 2 upon x is equals to a. This is the particular solution. I will solve the question number 4. Now the next question, reduce each of the following differential equation to variable separable form and solve it. Now see this here, dy by dx is equals to cos of x plus y. Now these are the important example. Here the substitution is x plus y is equals to u. Differentiate on both sides with respect to x. Derivative of x is 1, derivative of y is a dy by dx, that is equals to du by dx. Therefore the dy by dx is equals to du by dx minus 1. Now what is our differential equation? That is the dy by dx is equals to cos of x plus y. Substitute the value of dy by dx is equals to du by dx minus 1, and x plus y is equals to u. Therefore du by dx minus 1 is equals to cos u. Therefore du by dx is equals to 1 plus cos u. Now separate the variables, that is the du upon 1 plus cos u is equals to dx. But what is the value of, what is the formula of 1 plus cos a? That is the 2 cos square a upon 2. In the same manner, du upon 2 cos square u by 2 is equals to dx. Therefore 1 upon 2, that will become reciprocal of cos square u by 2 is a sec square u by 2 into du, that's equals to dx. Integrating on both sides, then you will get 1 upon 2 integral sec square u by 2 into du is equals to integral of dx plus c. What's the integral of sec square u by 2? It's a tan of u by 2 upon derivative of u by 2, which is 1 upon 2. And after finally it will become multiplied and reciprocal, and here is that 2. Therefore 1 upon 2 tan of u by 2 into 2. Integral of dx is x and plus c, and resubstitute the value of u. That is, this 2 get cancelled, you will get tan of u by 2 is equals to x plus c. Resubstitute the value of u. What's the value of u? U is x plus y. Therefore tan of x plus y upon 2 is equals to x plus c. And this is the solution of the required that differential equation. Now the next is x minus y bracket square into dy by dx is equals to a square. Now here the substitution is u is equals to x minus y. Now differentiate this with respect to x. Therefore du by dx is equals to derivative of x is 1, and derivative of y is a dy by dx. Therefore dy by dx is equals to 1 minus du by dx, and after all we are finding the value of dy by dx. Therefore the value of dy by dx is equals to 1 minus du by dx. Substitute it here, then you will get, that is a x minus y is u, and therefore it is a u square. What is the value of dy by dx? 1 minus du by dx. Put here in bracket 1 minus du by dx is equals to a square. Now simplify this, 1 into u, that is u square. U square into du by dx, that is u square into du by dx is equals to a square. And therefore you will get u square minus a square is equals to u square into du by dx. Therefore dx is equals to u square upon, if we simplify this, then you will get u square upon u square minus a square into du. Now integrating on both sides, that is integral of dx is equals to integral u square upon u square minus a square du plus c. Now what is the integral of this dx is x. Now see this integration. जर तुम्ही chapter number 3, 4 जर चांगले केले असतील तर तुम्हाला हे इंटिग्रेशन सहज जमेल. Now here is a u square upon u square minus a square. Add minus a square and plus a square and separate the variables. Therefore integral of this dx is x, and integral of, पुन्हा ते आपण separate पण करणार, u square minus a square plus a square and separate it, split up it. Then you will get integral u square minus a square upon u square minus a square plus a square upon u square minus a square. म्हणजे इथे आपण काय करू की minus a square plus a square केला आणि तो split up केला. Now u square minus a square upon u square minus a square is 1 plus a square upon u square minus a square bracket complete into du, that plus c1. What's the integral of 1 with respect to u? Is u. And what is the integral of 1 upon u square minus a square? It is of the form integral dx upon x square minus a square. हे सगळे फॉर्म तुम्हाला माहिती पाहिजे. That is a square upon 2a log of u minus a upon u plus a plus c1. And here is a x, substitute the value of u, which is x minus y. A square upon 2a square, that's you will get a upon 2 log of the value of x u is x minus y minus a upon x plus y plus a plus c1. Therefore, on both sides the x's get cancelled. Bring this minus y to the left hand side. Then you will get y is equals to a upon 2 log of x minus y minus a upon x plus y plus a plus c1. And after simplifying, multiply on both sides by 2. Then you will get 2y minus 2c1. That's equals to a log of x minus y minus a upon x plus y plus a. And replace the value of minus 2c1 as a c. And therefore, this is the solution. What is that? 2y plus c. That's equals to a log of in bracket x minus y minus a upon x plus y plus a. This is the solution. Now the next problem, that is x plus y into dy by dx is equals to sec square in bracket x square plus y square. Note this substitution. What is substitution? X square plus y square is equals to u. Now differentiate on both sides with respect to x. Then you will get the derivative of x square is a 2x, derivative of y square is a 2y into dy by dx, and derivative of u with respect to x is a du by dx. Therefore, cancel on both sides by, or take the 2 as common. Then you will get x plus y into dy by dx is equals to 1 upon 2 into du by dx. And now this is the, that is x plus y into dy by dx. This is the value. This is the equation, that is x plus y into dy by dx, that is equals to sec square in bracket x square plus y square, which we have given. Now we'll substitute the value of x plus y into dy by dx, which is 1 upon 2 into du by dx. That is 1 upon 2 into du by dx is equals to sec square u. And separate the variable, that is the du upon sec u is equals to 2 dx. Now separate the variables, that is the cos u into du is equals to 2 dx. Integrating on both sides. What is the integral of cos of u? That is the sine. Integral of dx is x into 2, that is the 2x plus c. Resubstitute the value of u. What is the value of u? That is the sine of, value of u is the x square plus y square. Therefore, the sine in bracket x square plus y square, bracket complete, that's equals to 2x plus c. And this is my answer. Answer given in the textbook is a different one. This is my answer. If you agree, then write down this answer. Now the problem number 4. What is that? Cos square in bracket x minus 2y is equals to 1 minus 2 into dy by dx. This is 1. Equation number 1. Now substitution here. What's the substitution? That is u is equals to x minus 2y. Now again differentiate this with respect to x. Therefore du by dx is equals to derivative of x is 1, derivative of y is the dy by dx. Therefore du by dx is equals to 1 minus 2 into du by dx. Sorry, dy by dx. Therefore the equation 1 becomes the value of 1 minus 2 into dy by dx is du by dx. Therefore the cos square u, this equation number 1 becomes cos square u is equals to du by dx. Separate the variables. Du upon cos square u is equals to dx. Now integrating on both sides, then you will get sec square u into du is equals to integral of dx is x plus c. Now integral of sec square u is a tan u, that's equals to x plus c. What's the value of this u? The value of u is x minus 2y, that's equals to c, that's equals to x plus c. And therefore our required solution is x is equals to tan of in bracket x minus 2y minus c1. Replace the value of the minus c1 as a c, and therefore the required solution, which is the final one, that is x is equals to tan in bracket x minus 2y plus c. And in this way we have completed the problem number 4. Now the next fifth one. Now the last problem from the exercise. That is in bracket 2x minus 2y plus 3 bracket completed into dx minus in bracket x minus y plus 1 bracket completed into dy, that's equals to 0. When x is equals to 0 and y is equals to 1. Now here, that is a in bracket 2x minus 2y plus 3 bracket completed into dx minus in bracket x minus y plus 1 into dy is equals to 0. Therefore dy by dx is equals to 2x minus 2y plus 3 upon x minus y plus 1. Now take the 2 as common, then in bracket x minus y plus 3 upon x minus y plus 1. This is the 1. Put x minus y is equals to 1. Differentiate this with respect to x. Derivative of x is 1. Derivative of y is a dy by dx and u is a du by dx. Therefore dy by dx is equals to 1 minus du by dx. And therefore our equation number 1 becomes, what is that? 1 minus du by dx is equals to, this is the 2u plus 3 upon u plus 1, and separate this, that is 1 minus 2u plus 3 upon u plus 1, that is equals to du by dx. After simplifying, you will get u plus 1 minus 2u minus 3 upon u plus 1, that is equals to du by dx, and that is a u minus 2u, that is a minus u, plus 1 minus 3, that is a minus 2 upon u plus 1. Take minus n as common, then in bracket u plus 2 upon u plus 1. That is equals to du by dx. Therefore, dx is equals to, minus dx is equals to du upon u plus 2 upon u plus 1. Therefore, minus dx is equals to u plus 1 upon u plus 2 into du. Now, this can be written as in this manner, that is u plus 1 upon u plus 2 into du is equals to minus dx. Now, integrating, we get that integral u plus 1 upon u plus 2 into du is equals to minus integral dx plus c. Now this can be written as in this manner. Now the power of this rational fraction, that is u plus 1 and u plus 2 both are same. We can arrange it in this manner. That is, if you completed the integral from the indefinite integral from the chapter number 3, then you can understand this. U plus 2 minus 1 upon u plus 2 bracket completed into du. Integral of dx is minus x plus c, and split of this u plus 2 upon u plus 2 is 1 minus 1 upon u plus 2 bracket completed into du. Now the integral of 1 with respect to u, du is u minus, what is the integral of 1 upon u plus 2 is a log of u plus 2, that is equals to minus x plus c. Substitute the value of u, which is x minus y, minus log of x minus y plus 2, that's equals to minus x plus c, and bring this minus x to the left hand side at x plus x, that will become 2x minus y minus log of x minus y plus 2, that's equals to c. This is the first one. Now when x is equals to 0 and y is equals to 0, put this in this equation. X is 0, y is 1, that is a 2 into 0 minus 1 minus log of 0 minus 1 plus 2, that's equals to c. Therefore, overall you will get minus 1 minus log of 1 is equals to c, and therefore c is equals to minus 1. That is a log of 1 is 0, and that's why the value of c is minus 1. Put this value of this c in the equation number 1, and therefore you will get 2x minus y minus log in bracket x minus y plus 2, that's equals to minus 1, and therefore 2x minus y minus log x in bracket x minus y plus 2 bracket complete plus 1 is equals to 0, and this is the particular solution. And in this way we have completed the exercise 6.3. I will see in the next video. Goodbye.